So hello and welcome. My name is Mustafa Al-Bahai. I would like to introduce AT Instruments, an AI automotive startup targeting vehicle cybersecurity and safety. So our product is Cpyr, aiming the contextual understanding of the vehicle situation through harnessing the power of computer vision to detect the driver, passengers, and traffic status, plus the power of deep packet inspection for the inter-vehicle bus communication, detecting anomalous behavior, and streaming videos and anomaly analytics over the cloud to the mobile app. So, our motive. Autonomous features helps in avoiding many accidents, but over-reliance over autonomous features or wrong perception of sensors could lead to accidents in many situations. So, as you can see, in unsafe speeds, following too closely, autonomous features prove to be causing more accidents than normal cars, due to, as I said, over-reliance or wrong sensor perceptions. So, in order to prevent such hazards, we need to predict collision in order for the driver to smoothly avoid or take over during any kind of obstacles or hazardous driving situations. We need to fuse multiple AI models running on independent inputs like vision and vehicle bus communication. We need an intelligent analysis to detect unknown hazards and threats that were not accommodated during car design, aka safety of intended functionality. So, what Cpyr offers is prediction collision warning and for any traffic dangerous circumstances, coaching the driver during such hazardous situations, driver vehicle DNA. So for every driver, and our AI models could make a profile for this driver and detect when the driver is not acting like he used to be. Vehicle to mobile video streaming. We could, as I said, we could stream videos over the cloud to the mobile real time for mobility as a service and fleet management support. And of course, there's video on demand for insurance claims. And to verify any kind of accidents and exterminate any kind of false accusations to the driver. So basically, what we're targeting is a complete situational contextual understanding. Solution is quite simple. Traffic elements detection, driver detection, all of this plus vision anomaly, plus the inter-vehicle contextual understanding, and all of this are getting fused to our AI model to predict the likelihood of collision. Solution is quite simple. Our just a Jetson board or NVIDIA AI board, normal NVIDIA board, different from 1 up to 8 webcams, which could span different kinds of and sizes of vehicles to make a complete vision coverage. Plus, of course, our mobile app, which is quite simple. You could just select the car from the fleet, and you could start directly giving commands to this car over the cloud. Now, our technology is based on NVIDIA DeepStream SDK, Jetson TX2 module. This is what we tried, but we can actually accommodate more advanced modules from NVIDIA. Our back-end cloud service is Microsoft Azure with video streaming capabilities and storage, of course, from Azure. So basically, the cost of operation is simply the cloud service subscription, and the maintenance could be done over the air. And distribution is simply, you can get an NVIDIA kit and any kind of general purpose desktop cameras starting from $20 to 4K cameras. So yeah, solution is quite simple. It could cost you about $120, $130. So let's go to our testing scenario. We used Euro NCAP scenarios for example, this one is for lane keep assist, in order for our model to get trained. Plus, we used the SOTIF standard in order to feed such scenarios with cybersecurity or user misuse or wrong sensor perception. So basically, we mixed both the Euro NCAP and the SOTIF in order to generate really stressful scenarios and check how would our AI model behave. So let's go to our first demo. So vision and deep packet inspection. Here I'm going to show you our first demo. We are here having the vision anomaly plus the LKA anomaly. So let's run that. So here the driver is recklessly driving. He's not very well aware of maybe he's drowsy or something. And you can see that the vision anomaly is scoring very high score. However, the inter-vehicle communication is not buzzed by this. When we are subjecting a fuzz attack, however, you can see here that the inter-vehicle communication is recording as well that there is something wrong between the communication of the ECUs plus the vision anomaly. Now, combining both, you are more sure that there is a problem and eliminates the false positives. Now let's go to the second one on a real life scenario Cairo streets, on the busy Cairo streets. Here's a traffic recognition or traffic status is recording if there is any kind of hazardous events. So you can see, for example, this black car has overtook, and you can see the high scoring of the precondition collision warning based on traffic analysis. And this is simply what we offer, is a complete contextual understanding of the situation. We hope you enjoyed our presentation. Please feel free to contact us anytime, and we hope to see you at the World Congress Conference